All right, here we are again. I'm going to work through another example, and then I might elaborate on the some of what we saw for the first example. Okay, so here I have an example that I'm going to work through. So I make the slides big. So let's see. I have a piece of material that is under the following stresses here. And it's under the following stresses here, like so. At this state of stress, we have something that is sigma equals P over A equals 56 kips over 0.5 inches times 2.0 inches equals 56 KSI. Okay, 56 KSI. So in other words, this is the state of maximum normal stress, and the plane here, the cut plane at the state of maximum shear stress has a width W of 2 inches. However, we wish to find the actual width, the actual width of the object. So if you imagine rotating through various cut planes, each cut plane will have a slightly different length, then we're going to call that W, width W. The material thickness is going to be constant because that's not changing as we're rotating. So the 0.5 inches represents the material thickness. This represents the width of the cut plane. And so this is the maximum. This is the only stress this thing is under because this is at the state of maximum normal stress. And here, this can be our point V and our H. And so I want to find the actual width of the sample. In other words, I am told that the width of the maximum of this plane, width of the principal plane is 2 inches, but I want to find the width of the actual object. So the width of the principal plane is 2 inches, but I wish to find the width of the entire object. So that's just going to require a little trigonometry. No, actually, not a little trigonometry, a little math here. If you can't remember which type of math, we'll just say it's just a type of math. Here. So we have this here because we are shown here that there is only a x shear stress here, or sorry, x normal stress here. There's only a sigma x, not a sigma y. So our lower point is just 0. So previously we started with a two arbitrary points that weren't the 2 points that were not the principal stresses, and we solved for the principal stresses. Here I'm given the principal stresses, and I want to back solve for the average. So I'm going to sketch a circle. Wonderful circle, a perfect circle as I always draw them. And this is 56 KSI. And this represents V and H. And the average here, the average stress is going to be 28 KSI. 56 plus 0 divided by 2 is 28 KSI. So here, sigma average equals sigma x plus sigma y over 2, which is equal to 56 plus 0 over 2, which is 28 KSI. And then the radius is simply going to be the distance between here and here, which is 28 KSI. Or we could also say it's sigma x squared plus sigma y squared over tau xy squared. Now, the max normal stress is where the max normal stress is 56 KSI. That's fine. Let's see. But what about the here? So the max normal stress is 56 KSI. However, that's the maximum. However, what about the average? Let's see. So let's say that the this thing has a yield stress of, oh yeah, the yield stress on this F yield equals 134 KSI. Oh, what happened? The yield stress is 130. F yield is 130. Why does it keep exiting out of that? Okay, better. Equals 134 KSI. That's also provided. 134 KSI. So, and then we can say actual is less than or equal to allowable. Less than or equal to allowable. Let's see. And 56 kips over A equals sigma actual. So this thing has a load of 56 kips on it. Equals sigma actual is less than or equal to sigma y over fs. So this leads us to 56 kips over 0.5 times W equals 134 KSI over 2. So we could actually get away with a width of just 1.67 KSI if we'd like. So we only actually, oh sorry, not KSI, inches. We only actually need a width W of 1.67 inches. I know that's a little bit vague, but hopefully that eliminates some things. That makes sense? Okay. All right, I do have one other item. Let me see here if we have time. Yeah, we do. I might draw a bigger Mohr circle from the first example. I might draw a bigger Mohr circle for the first example and really illuminate where all this stuff is coming from, hopefully.
So we found with the minimum width what
Yes.
right?
Yeah.
Okay, so we weren't looking for the actual width of the cut.
Yeah, I guess not. That's fine. Okay, don't worry too much about that one. That's fine. Okay, so let me go back to the first example problem, and here I'm going to draw a more elaborate Mohr circle here. So let me draw this out and remind us where we started. So I'm going to draw a big axis. I'm going to take up the whole slide doing it because reasons. Because we need lots of space. And we have tau. Oh my goodness, why did it do that? We have tau and sigma, both in psi. Now, first, the way we do this is we first start by having our two known points, our h and our v. We have h down here, just plotting the points that we had. And again, all of this corresponds to the first example problem. H um, and V. And although, let me see, is this going to work as I've drawn it? Yeah, it'll be fine. And this is going to come through. I want this to come through like this here. And of course it erased part of it because reasons. V here. V. So we start by plotting the two known points, the H and the V. And then we recognize the center of the circle is where the line between them intersects the sigma axis, the x-axis. So sigma average is negative 200. Negative 200 sigma average. Then we form a circle from this, around this. We just trace a circle around here. Now this would best be done with a protractor, but oh well. Another perfect circle, as I always draw them. Okay. So the first thing I can find is my sigma 1 and sigma 2 based off of the circle. Again, to do this properly, you need to actually do this on graph paper using a protractor and a compass and a ruler. So sigma 1 here equals 1100 psi. Sigma 2, and you need to go away. Sigma 2, oh my gosh, is will be negative 1500 psi. Then I can project the top, and I can project a vertical line from the center of the circle to find the Tom X. And this is going to be Tom X equals negative 200, comma 1300, negative 1300, or Tom X equals 200, comma positive 1300. That's how you find the principal stresses. And again, the H and V came from the original state of stress. H is negative 1400, comma 500, and V is 1000, comma negative 500. All right. Then the point that we were looking at, the point that we wanted. Oh, let me also label a few things on here before I go for that point A on axis AA. The 2 theta p is here. 2 theta p is here, or 2 theta s is here. Also, 2 theta s, the other, let's see, that's 2 theta p, and also 2 theta s is to the other one. This is why we end up with 2 different theta s's. 2 theta s here, it all comes out of the circle. 2 theta s is 67.4 degrees. So I think it'll really help you to think of this stuff graphically. 67.4 degrees. All right, and this here is this 2 theta p. This angle here is 22.6 degrees. Then to point A, we're looking at plane A, what we asked for at that one point. It's going to be up here. this is 614, 1013. And but we were actually told the angle. So we found this after we found the point and the angle. So we were just told the angle, and it is 2 theta A equals 73.7 degrees. 73.7 degrees. Then to get the points, um, let's see. This is obviously let's see here. 1200 here, here to here. That's fine. This is from here to here. The distance from here to here is r cosine theta, r cosine of 51.1 degrees, which is equal to 821.6 psi. And the height here is r sine of 73.7 degrees minus 22.6 degrees, which is equal to 1013 psi. And I could also say down here, the width of this is r cosine of 51.1. This is all just comes out of the trigonometry and the equations of a circle. So I would encourage you to perhaps, when you're working through some homework problems, don't be afraid to actually graph the circle. It doesn't necessarily have to be super accurate. Maybe just use a compass. If you don't have a compass, just make do with something. Actually trace a physical circle, maybe with a cup or something, even if you want to, a dish or something, and try to work through the angles. And if you work through it, you'll really start realizing where these equations are coming from. All right, questions on this nonsense?
So that theta A, is that just, I mean, we obviously just named an arbitrary angle.
Yeah, the
But
theta
we
A
use
was,
the angle in the circle to find, I mean, to find all the stresses that we found.
yes, we
We
first
did it
found the
that way,
circle
right?
using the H and V points, and then we found the theta A was given to us,
Right,
but then we wanted to find the stresses.
right.
Okay, so theta A is what's called theta A is the actual rotation in the physical system. But then when we translate it to the Mohr circle, we have to double the theta A,
Okay.
and that's where the 2 comes from. And I know this is a bit messy. It's kind of hard to draw precise circles on a tablet. So, all right, did that make sense? Okay. If you have any questions, feel free to email me or contact me during office hours. And a shorter lecture today, that's okay. And I think we'll talk about this more in the future. All right, thank you.